Supporting connective tissues. These are the connective tissues that are more solid than liquid. We are talking about bone and cartilage here. So there are going to be 3 types of cartilage that you learn, and there are 2 types of bone, but you only learn one of them in this set of notes. I'll tell you about the other one. You won't be responsible for histology slide for it. So let's start talking about cartilage and bone. All right, first off, let us revisit our organization, and let's just go ahead and continue our organization. So with the supporting connective tissues, which is where we are now, you have cartilage, C-A-R-T-I-L-A-G-E, and then you have bone. Okay, I'm just going to write all of these down now so that we can be finished with this whiteboard. There are 3 types of cartilage. There is hyaline. Cartilage should be after that. There is elastic cartilage. Don't leave out the cartilage. I'm just running out of room. And then there is fibrocartilage. So hyaline cartilage, elastic cartilage. And then with bone, which we'll do after hyaline cartilage, there are 2 types of bone. The one that you actually are going to be responsible for the slide on is called compact bone. And then this one exists. You'll learn about it in the next set of notes. We don't usually make you do the slide of it now. And it's called spongy bone, or sometimes cancellous bone. And then let's just go ahead and finish this story so that we can use the whiteboard for other stuff. Then after we're finished with the supporting connective tissues, the last connective tissue is the one that is the fluid connective tissue, and that one is blood, which doesn't seem like a connective tissue at all, but remember, what they all have in common is that they're derived from mesenchyme. All right, so now we are going to do cartilages first. Okay, all right. So the supporting connective tissues include cartilage and bone, and there are 3 types of cartilage, but they all have some things in common. And what they have in common is that the matrix, all of this part that you're seeing right here, the matrix right here, all this right in here that isn't cells, the matrix is semi-solid. So I think that cartilage, the matrix, kind of has the texture of if you leave Jell-O uncovered in the fridge for a little while and it gets kind of sprungy, like unpleasant to chew on, won't really give very easily. That's kind of the texture of the cartilage matrix. And what you have in cartilage matrix is, even if it's not visible, there's a dense network of fibers in the matrix, and fluid around it. It's not completely fluid like it is with, for instance, blood. So it's going to be tough, but it's going to be more flexible than bone. And you guys have probably experienced cartilage before if you've ever cut anything up, if you've ever eaten something with bone and gotten a little bit of that springy stuff in your mouth. Unpleasant to think about, but now I want you to know, to have a connection with what it's like. Inside all 3 of the cartilages, the cells are called chondrocyte. The prefix chondro, remember, means cartilage. And they sit in a space that is called a lacuna. So let me just draw you a general cartilage before we get into more details about it. Okay, so what is a general cartilage like? A general cartilage is going to have, okay, so you're going to have generally these big white frames around, and then a cell within it. This looks like I'm drawing a happy face. I'll draw one more so it doesn't look like a face. And as far as labeling goes, what you're going to have is this space that usually is bright white around the cell is called a lacuna. Plural is lacunae. Excuse me, gotta take a drink of water. And then the cell within the lacuna is called a chondrocyte. And then all of this stuff out here, oops, that's not what I wanted. All of this stuff out here is the matrix. So all of this out here is the matrix. And in some of the cartilages, you have visible fibers in the matrix, and in some of them you don't. So the metaphor that works for how cartilage seems is like putting grapes in Jell-O salad, because the grape is a physical entity and the Jell-O will form all the way around it. But if you take the grape out, and in this instance, the metaphor of the grape is the chondrocyte right there. If you take the grape out, there's still going to be an empty space, a concave space for the grape to sit in. So the space where the grape was the lacuna, and the grape itself was the chondrocyte. Now, it forms differently though, because the cells were actually there before the matrix. What the cells do is they make the proteins and the matrix and they secrete it around themselves, but then they still give themselves a space to sit. So it's like a Jell-O salad if the grapes made the Jell-O. Okay, so now let's meet the three types of cartilage and talk about cartilage a little bit more. So cartilage is a supporting connective tissue. It's more flexible than bone, as I mentioned. One of the important things about cartilage is that it, within the body of the cartilage itself, like if you're looking right here, if you're looking here, you don't see any blood vessel cross sections going through that. It's a really thick tissue with not a whole lot of blood supply going directly to it, and that matters because that means that it heals relatively slowly. If you damage cartilage, it tends to stay damaged. The only way that cartilage actually gets its nourishment is by the tissues that are around the cartilage. So let me show you this really quickly. So the cartilage itself is all right here, but this tissue out here is actually perichondrium, and this has blood supply to it. And so that means that like the cells that are at the edge of the cartilage might get a pretty decent blood supply, but as you get toward the middle, not great blood supply for repair and regeneration. So for instance, if there's any of you I have who have pierced your ear up here where it's cartilage, even if you no longer wear an earring, you've still probably got damage because it doesn't heal. By the same token, this tissue at the end of your nose, if you run your finger down your nose and you can feel where the bone ends because you can start to feel it get wiggly, this tissue at the end is hyaline cartilage, and it doesn't repair either very well, which is why a nose job will actually work. If it were bone, the bone would just regenerate and repair. Okay, so let's talk about the three types of cartilage. So the first one here is the most abundant cartilage that we have, and it's called hyaline cartilage. And the word hyaline in this context means glassy or smooth, because the matrix of hyaline cartilage compared to the matrices of the other two cartilages, this one and this one, do you see how smooth, meaning not visible fibers, there are in hyaline cartilage? So that matrix is relatively smooth. So it does have collagen fibers, but you don't have to label them because they aren't distinguishable. And so where do you find this cartilage? This cartilage is really common. It forms most of your fetal skeleton before you actually had bones. It is, like I said, the tip of your nose. If you go down your nose and start wiggling this part, this is hyaline cartilage. It forms the larynx and the rings of your trachea. It forms most of what we call your articular cartilage. And articular just means the cartilage that forms joints. Most of your articular cartilage is made of hyaline cartilage. And these costal cartilages that connect your ribs to your sternum, those are made of hyaline cartilage. So this is hyaline cartilage, but let's look at a few more pictures. So what you will see in hyaline cartilage, first off, you need to be able to recognize that it's a cartilage. For me, that's that the cells look like they have white frames, lacunae around them. Not necessarily every one, but certainly most of them, and that's different than what we saw in other tissues. So here again, cell with a lacuna around it. And then how do you tell it's hyaline? Well, notice that there aren't any distinct fibers in the matrix. And this is hyaline cartilage really, really close up. So this white space that you were seeing right there is the lacuna, that's the chondrocyte, and this is the matrix. This is hyaline cartilage. Okay, so let's look at the other two types of cartilage. The next type of cartilage has visible elastic fibers in the matrix and the frames, the lacuna around the cells. Notice that the fibers tend to be dark and thin, which tells you that they're probably going to be elastic fibers. And the cells have nice bright frames around at least some of them. This is elastic cartilage. It's more flexible than hyaline. It's not as common as hyaline. The places that you can run into elastic cartilage are this pinna of the ear, not the bottom part that doesn't really have cartilage in it, but the top part, it's boingy. Spoing, spoing, much more so than your nose. So the pinna, the external ear, the epiglottis that keeps you from literally inhaling your food, and the auditory or eustachian tubes are all made of this tissue. And let's look at a couple more iterations of it. Here's another one. Again, this is way closer up, but do you see those dark fibers, really branched, relatively dark in the matrix with nice bright frames around the cells? That's elastic cartilage. And this one's a beautiful one. Nice bright frames around the cells, really dark branched fibers in the matrix. That's elastic cartilage. That one's elastic cartilage, not a beautiful slide, but it's still elastic cartilage. Okay, and then the last cartilage is fibrocartilage. And fibrocartilage has, of these three, it's the one with the parallel fibers in the matrix. It usually stains blue, but don't ever depend on colors as your only memorization tool because they're all different staining techniques. So don't memorize colors only. So it has, again, cells with these bright frames around them. Doesn't have to be all white. So do you see with the cells with the bright frames around them even here and here? And notice that the fibers in the matrix are relatively parallel. These fibers are collagen fibers. I know you're used to thinking of collagen as being pink, but this is a good time to get over memorizing colors because this is a different staining technique, and the collagen in fibrocartilage usually stains blue. So what do you think about the strength of a tissue that has bundled collagen fibers in a relatively solid matrix? This one is going to be a really, really strong cartilage. It's the strongest of the cartilages, and you use it where you have a lot of stress that goes between often two bones. For instance, you can see here the intervertebral discs, not the ligaments, intervertebral ligaments, which we talked about before, which were made by elastic, dense connective tissue, but the actual discs in between, like when somebody says they've slipped a disc or torn a disc, they are talking about fibrocartilage. So these are intervertebral discs, or the pubic symphysis between your two pubic bones, that is fibrocartilage. And you have a lateral and a medial meniscus in your knee, and those are made of fibrocartilage as well. Your knee actually has two kinds of cartilage in it. It's actually got, at the ends of the bone, it's actually got hyaline cartilage, but then the knee is under so much stress that it's actually got two extra pads of cartilage. Those are fibrocartilage. Okay, so we'll stop there and we'll do bone in the next one.